Welcome back to this course on machine learning using Python programming. In the last lecture, we have seen Occam's razor principle and pessimistic error, and we have seen the importance of these in selecting different models of machine learning. Now, we will see another classification technique, that is very popular classification technique, k nearest neighbor. So, let us see what is nearest neighbor rule classifier. So, here I am not talking about k nearest neighbor, I am talking only nearest neighbor or nearest neighbor classifier. So, what is this nearest neighbor classifier? How we will classify using nearest neighbor classifier? So, first of all, we will definitely have the training data set. So, in the training data set, we will or we can say that in the training phase, we will store all these training examples in the memory, and then during the testing time or during the prediction time, what we will do, we will test which instance in our data set is the closest to the test instance, and then we will predict the y value or the response variables value of the test instance as the response variable value of this closest instance. So, how nearest neighbor classifier works? For the given for the given test data for which we want to find the value of response variable, we will find one of the instance from our data set that is closest to this test data, and then the response variable value of that instance we will predict as the response variable of the test instance. So, in this way nearest neighbor classifier works. So, what we are doing, we are finding the nearest neighbor of the test data. So, nearest neighbor, how we are finding? We are saying the nearest neighbor is that particular instance that is closest to the test instance. So, closest to the test instance we can define using any distance metric, and we can find distance between all the data points in our training data set, and we will find the distance between test data and all the data points, and the data point for which this distance is minimum, we will define that as a nearest neighbor of this test data, and using that nearest neighbor's response variable value, we are predicting the response variable value of the test data. So, the problem with this approach is, suppose the nearest neighbor that you found, that is the outlier. So, if this is outlier, in that case your prediction will be wrong, and that is why there is a concept of k nearest neighbor, means we will not only find the nearest neighbor of the test data, we will find k nearest neighbor of the data. So, we have seen how k nearest neighbor can be used for regression problem, and in that case we have seen this k nearest neighbor is instance based learning, it is not model based learning. What is difference between instance based and model based learning? In case of instance based learning, you are not creating any model, you are simply when a new data is coming for which class is to be predicted. So, that instance will be used for all the processing, and so we can say that during the testing time itself all the processing is done, and that is why it is called as instance based learning. It is not the model based learning, because no model is created during the training phase, and that is why it is also called as lazy algorithm, because everything is done during the test phase in the training phase we are we can say that we are only storing these training examples or training data set in the memory, and that is why it is also called as the lazy algorithm. So, and this k nearest neighbor can be used for non-linear classification also. It is very compute intensive, because we have seen in case of nearest neighbor, what we are doing, we are finding the nearest neighbor of the test data. So, how we are finding nearest neighbor? By we are calculating distance of this test data with all the data points in the training data set, and so we will use some distance metric and we will calculate that distance metric for all the training for all the instances that we are having in our training data, and that is why there is but we have seen that there is a problem in case of nearest neighbor. So, we will use k nearest neighbor. So, here we will find k nearest neighbors of this test data. So, how we will find k nearest neighbor of this test data? In that case also we will need to use some distance metric, and we will calculate that distance metric for all the instances in our training data set. So, that is why it is very compute intensive, and the other problem is we will need to define what should be the value of k. There means generally we take any odd number for k, and basically we take it odd, so that we can break the tie, and 5 is generally taken as the default value of k. So, how we do it? We can say that for calculating distance of test data with all other instances in the training data, we use different we can use any distance metric like Euclidean distance, cosine distance, Manhattan distance, Hamming distance, and so on. So, it will depend on the problem and the data set, or we can say that depending on the features, whether these features are categorical or continuous. Based on that we will decide which particular metric we should use, and then what we do, suppose using this distance metric, we found the k nearest neighbors of the test data. So, after finding k nearest neighbors of the test data, what we will do? We will see the majority class of from these k nearest neighbors. So, suppose there are 5, k is 5. So, we identified 5 nearest neighbors of the test data, and out of these 5 nearest neighbors, 3 instances class is C1, 1 instance class is C2, and one instance the remaining one instance class is C3. So, the majority class for this k nearest neighbor is C1. So, we will predict C1 as the class for test data also. So, this is the k nearest neighbor algorithm, and this k, why we are taking k nearest neighbors to so using this k we are basically taking care of outlier that we have seen in case of nearest neighbor. So, if we will take the value of k as 1, there are chances that if the nearest neighbor is outlier, your prediction will be totally wrong, and in that case we are trying to reduce the effect of that outliers. So, we are taking more than one nearest neighbors. So, suppose k nearest neighbors, and then we are based on the classes of those k nearest neighbors, we are finding the class of this test data also. So, since these 5 nearest or k nearest neighbors are very close to the test instance, we can assume that the y value or the classes of these nearest neighbors will give you some hint for class of the test data also. So, in the majority voting approach that we have seen, that we will take the majority vote, means the instances that are in the k nearest neighbors, the class that is having the majority vote, we will assign that class to the test data. So, in that case what we are doing, we are treating all the k nearest neighbors equally, while their distance from the test data may be different. Maybe there are chances that 2 nearest neighbors are very close to the test data, while remaining 3 nearest neighbors are far from the comparative to those 2, it is far from the test data. Even then we are treating all these instances. So, suppose for the remaining 3 instances that are far, their classes is same, and that class is suppose red, and for the 2 instances that are very close to the test data, their class is green. So, here we are talking about majority votes. So, we will assign red class to the test data, because the red class is the majority in these nearest neighbors, and that is why in case of majority voting approach there may be problems. So, sometimes what we do, we reduce the impact of this k using weighted, we give the weight to each data, to each nearest neighbors based on their distance. So, what we do, we calculate this weight for each and every nearest neighbor, and then suppose and this weight is basically we are since we are calculating this weight based on the distance. So, the nearest neighbor that is closest to the test data, its weight will be high, and the nearest neighbor that is the farthest to the test data, its weight will be low. And then we will calculate the weight of all the classes, and we will assign that particular class for which the sum of weight is maximum. So, these are the 2 ways, and in this way we may better predict the class of the new instance, because we are first of all we are finding the k nearest neighbor, and then we are considering distance also. So, not only we are treating all the instances equally, we are giving weights to different instances based on the distance that they are having with the test data. So, in this way we are predicting the class of that new instance. So, this is k nearest neighbor. Now, we can say that weighing example from the neighborhood in case of k greater than 1 means there are 2 ways to improve simple KNN where k may be 1. So, first of all we should choose k that is greater than 1, and the other improvement is we are not considering all the neighbors equally, we are giving them weights corresponding to distance of those instances with the test data. Then how to measure closeness? We have seen that you may have many distance metrics. So, we can choose any of these, and then how to find the closest point quickly. So, when we will implement, we have discussed that the computationally it is very intensive, this KNN algorithm, and that is why sometimes we implement our algorithm such that it will take very less time to compute the k nearest neighbors. So, what we will do, we should use some good data structure, or we should use some methods to store these training data points such that when we are calculating distance. So, it is not necessary to calculate distance from all the data points to find out the nearest neighbor. So, if we are finding some nearest neighbor, so it would be good if it is not necessary to compute distance from all the instances. So, there are some methods, there are some data structures, we should use those ways to reduce the computational complexity of the k nearest neighbor. Let us see now one example here quickly. Suppose these are the two categories. So, star are representing the first category, means first class. So, these are the data points that are belonging to first class, and these triangles are representing the instances that are belonging to second class. And now we are getting a new point, and we need to find the class of this new data point. So, we will need to predict whether it is belonging to category 1 or category 2. So, after applying any classification algorithm, and here we are assuming we will apply KNN. So, after applying KNN, suppose we are getting this the class of this new instance is category 2, class 2. So, how it will be done? These are the steps. Let us see these steps quickly. First of all, we will need to choose the number k of neighbors. Okay, how many in our algorithm, what will be the value of k, how many nearest neighbors we are going to choose. Then take k nearest neighbors of the new data points according to the Euclidean distance. So, we are assuming we will use the Euclidean distance, and using this Euclidean distance we will find k nearest neighbors of this new data point, for which we will need to find the class, we will need to predict the class. Then among these k neighbors, we will count the number of data points in each category. So, in the first category, how many data points are in these k nearest neighbors, and in the second category, how many data points are there in k nearest neighbor. Then assign the new data point to the category where you counted the most neighbors. For the category for which number of data points are large in k neighbors, you will assign that class to the new instance. So, let us see this. So, this is the new data point, and we are trying to find the class of this. So, suppose we are talking about 5 NN, means k is 5. So, what we will do, we will first of all we will find the first nearest neighbor. Suppose when we will calculate distance of this with all these data points, then distance between this and this is the minimum. So, this is the first nearest neighbor. Then we will find the second nearest neighbor. So, suppose this is the second nearest neighbor of this point, then this is the third nearest neighbor of this point, this is the fourth nearest neighbor, and then this is the fifth nearest neighbor. So, how we got these nearest neighbors? Using the distance of these data points with this new data point. And then what we will do? So, we now got all these 5 nearest neighbors. We will calculate how many data points are out of these 5 nearest neighbors, how many points are of category 1 and how many points are of category 2. So, there are 2 points are of category 1 and 3 points are of category 2, and that is why we will assign category 2 to this new instance. So, in this way, this is a very simple algorithm. Here we are not you see we are not taking distance into account, because this data point is the closest data point. So, its distance is you can say this much, while this point is the farthest to this. So, its distance is, we can say that more than double of this distance. Even then we are treating them equal, or we are giving the same weight to both of these two data points, but we have seen the another variation where we can give different weightage to these data points, and based on this weight is basically distance itself, and then we will get better results. Now, we have seen the example of binary classification. We can use KNN for multi-class classification also. So, multi-class classification, in that case you will have more than 2 classes. So, if there are more classes, then how the KNN will work? So, it will work exactly the same way. We will count, in that case also we will count how many neighbors belong to each class. So, here there were only 2 classes. So, the nearest neighbor, either they belong to category 1 or category 2, but if suppose this is a 3 class classification problem, then there are chances that one of the nearest neighbor may be of class 3 also, and then we will do the same thing. We will calculate how many data points from the nearest neighbor are of class 1, how many data points from the nearest neighbors are of class 2, and how many data points from the nearest neighbor are of class 3, and then using the majority vote we will assign class to that instance. So, this is the algorithm. First of all, we will need to load the data, then we will initialize the value of k. So, it means we need to choose the number of neighbors. Then for each example in the data, we will calculate distance between query example, means your test data, and the current example from the data. Then add distance and the index of the example to an ordered collection. So, definitely we will keep these instances in a order of the distance from the query example or test data. So, we will sort ordered collection of distances and indices from smallest to the largest. So, we can say that in the ascending order we will arrange all these data points, and this ascending order of distance we will arrange these data points. Then pick the first k entries from the sorted collection. So, these k entries are nothing but the k nearest neighbors. Get the labels of the selected k nearest neighbors, and in case of regression, how we will find the prediction, how we will find the value of the response variable. We will take average, we will take mean or average of these k labels. So, basically in that case, for all k nearest neighbors you will not have labels, you will have k values. So, you will take mean of those k y values and you will get it in case of regression, and in case of classification you will take mode of the k labels. So, it will give you majority vote of these k labels will give you the prediction for the class of the test data. So, these are the pros and cons. So, it is very simple algorithm. So, k nearest neighbor is very simple algorithm, it is very easy to understand. So, generally we have lakhs of instances, and if your data set is image data or video data, in that case generally we have lakhs of images in our data set or lakhs of videos in our data set. If we are trying to categorize those, trying to find the classes of those images. So, in that case we need to save all the instances into memory, because what we are doing during the test time, all the instances are being used. So, what happens, we are calculating distance of test image or test data from the rest of the data in the data set. So, that is why all this data we need in the memory. This is the very big disadvantage of KNN, and that is why many other classification techniques that are model based techniques, where we during the training time we form a model and then we can leave the whole data. We will need to only store that model, and using that model we can find the we can do the prediction. So, that is why we can say this is the most disadvantage of KNN, because that we need to store all the data during testing time, during prediction time, and it is very compute intensive also, because during the test time we will need to calculate distance of all the data with the test data. So, it is better if we can find the decision boundary, that is nothing but the model that can be used during the test time. So, we will be able to discard all the training vectors, and we will only save only few parameters of the model that will define the boundary, and based on that we will be able to predict the class of the new instance very quickly. So, in this lecture we have seen KNN class for the classification problem. We have seen how KNN can be used for regression problem, and it can be used for linear as well as non-linear problems. And we have seen it is a lazy algorithm, because during the testing training time we are not doing anything, all computations are done during the testing time. That is why it is very compute intensive, and it requires a lot of memory if your data set is very large, but it is very simple, very easy to understand algorithm. And in the next lecture we will see some other classification algorithm. So, I am stopping here. Thank you.